This is for class 11, uh, class 11, that is circular motion on a level road. Circular motion on a level road. So here you see this is a circular curved path, that means it's a circular path. Here you see this is the circular path, and here this is your car. This is your car. It is taking a circular, a curve, circular turn. So here this is the friction which is acting inward, and the weight, this is the weight of the body, that is mg, and according to Newton's third law, this is the normal reaction n. So here your F, this provides your centripetal force, and F is equal to mv square by r. Your R, mv square by r. Your R, it is the radius of this circle, radius of this curve, and here n is equal to mg. This two forces in vertical directions are equal and opposite. So here your frictional force, it acts as a centripetal force. So this centripetal force must be less than equal to static friction. This must be less than equal to static friction. So here your mv square by r less than equal to coefficient of friction into mg. So this is v square will be equal to coefficient of friction g into r. So v less than equal to, so v is less than equal to root over coefficient of friction g dot r. So here your maximum velocity, the maximum when the car is taking a curve turn, so the maximum velocity of the car should be coefficient of friction g into r. If the velocity is greater than this, then the car will skid. Now the next topic is circular motion on a bank road. Your next topic is the circular motion on a bank road. Circular motion on a bank road. Next topic is the circular motion on a bank road. Bank road. Circular motion. So here you see that this is a bank road making an angle theta, and it is going here. This is uh, a circular path. Here this your car. Here this is your car. This is your car. This is your car, and this car is moving in a circular path, and the road is banked. That means it is the road is making an angle theta with the horizontal surface. So here this is your so here this is your frictional force. So here this is your frictional force, and this is the weight of the body. This is the weight of the body, and the normal reaction is always perpendicular to the surface. The normal reaction is always perpendicular to the surface, and here this is uh, perpendicular to this. So perpendicular to this. So this is parallel theta. So here this frictional force, it has a component here. This is F cos theta, and another component here, that is F sin theta. Similarly, your normal, it has two components. One is n cos theta, and another is here n sin theta. It has two components. So now this act as a centripetal force. This act as a centripetal force. Centri This act as a centripetal force. This act as a centripetal force. So here your centripetal force is mv square by r. This is equal to f cos theta plus n sin theta. This is your centripetal force. And next, this horizontal force, these are balanced, that is n cos theta is equal to f sine theta plus mg. So here your mg is equal to mg is equal to n cos theta minus f sine theta. So now this is equation 1 and this is equation 2. This is equation 1 and this is equation 2. Now 1 divided by 2, you are going to get, that is v square by rg. This will be equal to f cos theta plus n sine theta by n cos theta minus f sine theta. So this is the, when you divide 1 and 2, you get this result. And we know that frictional force, that is coefficient of friction into normal reaction. So let us divide both sides by uh, theta. So this is n cos theta and sin theta. I think so everything is correct. This is f cos theta, f sin theta. This is n cos theta, and here this is n sin theta. Now here you divide divide by n cos theta. You divide by n cos theta, v square by rg. When you divide by n cos theta, that is f by n plus tan theta, f by n plus tan theta, and this will be 1 minus f by n sin again tan theta, because I am dividing the numerator and the denominator by, I am dividing it by n cos theta. I am dividing the numerator and denominator by this n cos theta. So this is v square by rg, that will be coefficient of friction, plus tan theta 1 minus coefficient of friction tan theta. So here your v square will be rg 1 plus tan theta by 1 minus coefficient of friction tan theta. So v will be equal to this will be rg, this will be rg coefficient of friction tan theta by 1 minus tan theta to the whole power 1 by 2. Now, if your coefficient of friction is 0, that means it's a smooth surface. If this is 0, so your V will be equal to this 0, this 0. So this will be root over Rg tan theta. So this is your maximum. This is your maximum velocity in case of a banked road. So this is all about today. Thank you.